Okay, well, yeah, thank you all for being here. I really appreciate the opportunity to present some of this stuff, right? Some of the successes but challenges that came out of a COVID disrupted semester in the fall. And, okay, so what I'm going to describe are some modifications that were made to an experiential, hands-on, and field-based course called Environmental Field Methods. Because of COVID restrictions made by the UMaine system, of which UMaine Farmington is one of the constituent campuses, we couldn't travel. And that meant that everything had to be on foot, and it had to be, as a result, on and near campus. And the reason for no travel was not only to protect ourselves, but then also the potential service learning community partners. And so as a result, a number of us shifted things to use outdoor classroom space. We didn't really have formal outdoor classrooms, but we're able to use existing campus spaces for, content and pedagogy. And so, also because of changes to the physical distancing that was required, that changes how in-person collaborative work is done. You can't cluster around things quite as closely. There were other changes, right? We didn't have a fall break because the UMaine system wanted to discourage travel. And then the other thing is that because you can anticipate a rise in cases with the change in weather and then also Thanksgiving travel, we were definitely going to move our courses online at Thanksgiving, if not earlier, had circumstances dictated that. And so to handle all of these changes, what I did is I shifted lecture-based content delivery to later in the semester, and I front-loaded hands-on work. And I also built in 2 multi-week class projects that would have been done differently in a more typical semester. And look, being in Western Maine, we were really fortunate with the weather. It was dry, we didn't have any rain during class, and so that actually made this a little bit more possible. But we didn't face the environmental challenges that, can be anticipated with fall weather in Maine. And so the course that I'm describing, what it does is it accomplishes service learning using hands-on field methods training. And in the process, I build in a lot of problem solving. So for instance, if we're going to go out and do a bunch of transect or quadrat-based measurements of environmental variables, I have the students design and build these things. So what they built this year were point sampling frames with all these flags that you see. And we manipulate things. We dig holes to do percolation tests and, all sorts of things, right, that involve a different kind of problem solving than just the content delivery, but sometimes also figuring out how to make the materials that we're going to use. And then also how you deploy, microclimate stations and things of that nature. The 2 class research projects that I'm going to describe, they involved all the students, but the first one was a study of our brand new campus community garden. So what we did, service learning work for the campus partner, was to study the microclimates that are in this garden area as a way of understanding how some of the built environment features can be used to better effect for the garden and food production. And so what we did a bunch of hands-on in situ measurements, but we also deployed remote data loggers for 5 weeks. And what we were doing was looking at the effects of a nearby wall, right, that gets some sun, but then, so that wall radiates heat, but then it also casts shade. And so it produces microclimate effects that were worth looking at. The other thing is, and you can see behind this student, there are raised beds, traditional raised beds, but we also had physically accessible elevated beds with very shallow soil and a lot of air airflow below it. The other project was looking at the carbon sequestered in our campus forest. So we measured trees and then ran it through some models to calculate how much biomass and then standing carbon. We also paired that with tree cores taken from the campus forest that I'm not going to describe in depth today. So just to orient you to the campus garden, if you're seeing my cursor, is up here occupying the space that was previously, had a building on it. And so one of these trees was taken down, the other tree still remains, but you can see that, it's not maybe necessarily the site that you would pick, but it's the site that we had available. And so we then did a microclimate study comparing it to a south-facing amphitheater, which is too steep for gardening, but it provides a useful comparison in terms of microclimate sites. And so then the garden was built, and it has these various features, which then we put data loggers out there. And just to walk you through a couple of the results that the students developed for this service learning partner, right, the garden team, we found that soil and air temperature vary across space, but the things like the brick wall, it actually does elevate soil temperatures because of that proximity to the building and all of those things. There's also some sort of depressed soil temperatures in terms of the shade that existing trees cast, but basically because of air mixing, even where you have shade, the air temperature is relatively even across these transects. But I mean, plants are more responsive to soil temperature than air temperature anyway. And so, understanding where these lower soil temperatures, can then help the garden team with selecting which plants to grow. And then also thinking about, spring garden, summer garden, and then fall garden as a way of extending that productive season. Looking at other microclimate effects, looking at those, the raised beds versus those shallower elevated beds, the wheelchair accessible beds, which again have thin soil and airflow underneath them. Those physically accessible garden beds, they have colder soil and it's more variable soil. The measurements we took were in the fall. And so again, this provides an opportunity for thinking about what plants are selected for those, or if these elements can be buffered in particular ways. So for our service learning partner, this would be the faculty and, student groups who can maintain that garden. What we did is quite a bit of comparative data analysis, a whole bunch of stuff that's not, being displayed right here, a poster, an oral presentation, and then a written report, all of which was handed back to that community partner. And in the process, the students also generated certain recommendations to the garden team in terms of how to make use of the identified microclimate features to not only extend the growing season, but also maybe think about plant selection. And as the garden expands, to think about where a greenhouse might be best placed on campus as part of this growing garden initiative. The second project, again, was looking at carbon sequestered and stored in our campus forest. And our campus, forest is an interesting thing. It's an old boys' school that had been started by, a famous children's book author. And the map, below is a site plan of that particular thing. It had several lakes, it had a railroad in it, and a whole bunch of, architectural features. And this forest was designed by a well-known at the time landscape architect named Cleveland. And so, since that time, there's been a lot of forest succession and secondary growth that's been happening, among other landscape changes. So, we start with a designed and planned forest, and then, what we see today is actually quite different than what was designed. But there are some of these legacies still on the land, including some non-native to our particular region of Maine species that are thriving. And so what the students did is they planned the field work. They decided on how we're going to do this. They did it in belt transects that were 150 meters squared, and then we did a certain number of those. And then they also set the field plan. What are we going to measure? Well, it's tree diameter, but so what's going to be the size class of trees that we do? And then also gaining skill at identifying those things. And so those tree diameter measurements are then fed into some fairly simple allometric scaling equations. We came up with a sort of generalized model, but then there are species groups, and then also we can look at biomass components. And so there are different ways of kind of breaking out carbon that's stored in the forest. But the students ended up measuring a reasonable amount of space, a little more than half an acre. As another part of this, right? But there's variability on the ground. Students mapped out the entirety of this place called Abbott Park, and then subtracted out the grassy areas or the places with just one or two landscaping trees. And so they basically come up with this top line number of the nearly 3 forested acres of our campus forest contain probably 437 tons of carbon. And again, that gets broken down and refined in all kinds of ways by species type and, bole versus bark versus coarse roots versus foliage. And another interesting thing that they did is they kept track of seedlings and saplings. And so then the students were able to compare the campus overstory trees, the things that are sequestering the most carbon, and then make forward projections about how ongoing turnover and changes to the species composition are likely to affect forest carbon in the future. And so in service to our campus partner, and this is really more campus as a whole, you know, my classes and some of these actual students, like the ones depicted on this slide here, are continuing the carbon-based measurements. We're expanding it to more places on campus. We're going to continue coring trees, because tree measurements and basal increment calculations are another slightly more refined carbon storage calculation method. And so again, this is going to happen not only through classes that I teach, but through student hiring, lab positions. And another thing that we did is there's another campus forest that's walkable from our campus. It's this hilltop quaking bog. And we went out this winter when we had 2 feet of snow on the ground, and we did ground penetrating radar measurements. And I got the initial results from those yesterday. And this is going to allow us to calculate peat volume and as a result stored carbon in a really small quaking bog that's surrounded by hemlock forest. And so we did that field work, but then, you know, this is going to be partnered with a bunch more tree-based measurements. So, you know, I just want to conclude by saying that, you know, the campus environment, campus and near campus environments, they provide really robust and flexible settings for teaching stuff like physical geography, for teaching environmental field methods, and for teaching sustainability related courses. And this is true in normal times and also in pandemic times, because, you know, campus environments allow physical spacing. They allow us to be in a place where viral transmission is a lot less likely, right? Because of airflow, and we're not rebreathing so much stuff like we would in a classroom. But then also, you know, just because of the multivariate set of things that are available to study, which allows you to build in authentic and robust student-led inquiry that not only teaches concepts and content, but then also allows, you know, research practice, and in some cases, publishable manuscripts, which is where we're pushing with the peat bog and the campus forest work. And as a result, the campus environment provides opportunities for, you know, again, authentic undergraduate research, but professional skills building that can then help students land in post-college careers. So with that, I would love to take any, you know, questions or comments that you might have. I also want to point you down here to the bottom, where we maintain a departmental Instagram account that highlights some of our field-based and sustainability, you know, service learning and project-based work. So yeah, if you're interested in, you know, having a visual representation of more of our ways that we operationalize that, you can find it there. So yeah, again, I'd love to take any questions that you might have for the time that we have.